tough decisions. Okay. Yes. You don't have a packet. You weren't here when I asked about packets. You don't have a packet. Where did I put the packets? Where did I put the packets? Abby, hand this back to Sydney, please. All right. So, we are going to finish notes today on lesson 6. We are on the page that starts at the top with exercises 2 through 6. Why call it tangent? Why do we call it tangent? Who remembers what tangent is? What is a tangent? Not in trig speak, but in geometry. Who remembers what a tangent is? That's trig speak. There's another. There is a. So, here's what I call a tangent. I'm going to take a line. And I'm going to draw it such that it just skips along the edge of the circle. Just skips. Meaning it touches at just one spot, right? That line is a tangent of this circle. Okay, that's what it means to be a tangent. Okay? So why do they call sine theta divided by cosine theta a tangent? Here's why. You guys saw that line is tangent, right? We understand what the definition of a tangent line is in regards to a circle, right? I have a circle here. I call it my unit circle, right? Oops. That's my unit circle, right? Now this bluish line going from here, well, it's black here, but it goes all the way up here. That too is a tangent line. Does everybody see that? That is a tangent line. Now, I'm going to erase the black line, and you're going to see a couple different colors. You're going to see the black down here, Tabitha? Hi. And you see the blue up here. Does everybody see those parts? They're not black and blue on your handout, they're just black and black, right? But on my thing, they're black and blue. Because somebody took them out back and just roughed them up a bit. So, you guys are supposed to laugh. Polite, not sarcastic laughter, polite laughter. There you go. All right, so that's a tangent though, right? Now check this out. The tangent line, the tangent for this angle theta, it is opposite over adjacent, right? And we usually do it just out to the edge of the unit circle. But what they do is they extend the ray out past a certain point, right? And then they take this tangent line that connects, it is tangent right at this point at 1, 0, and it also connects with my ray up here. Now, similar triangle to the first triangle, right? So this red triangle that I'm going to draw is similar to this green triangle, yes? Do we see that? They are similar, meaning this angle is the same in both triangles. Okay, now, what is the tangent of this angle? What is the tangent of that angle? It is opposite over adjacent is one way of looking at it. So it's this, the length of this line divided by this line, or I could say it's the sine of theta over cosine of theta. That's one way of looking at tangent. The other way is opposite over adjacent. Now, when I extend that ray out and I look at the red triangle, opposite, I want to do this in red, I got opposite over adjacent. Now, in the red triangle, what is the length of the adjacent side? Remember, it goes to the edge of the unit circle. What's the radius of my unit circle? 1. Why is it 1? Because reasons? No, not reasons. Because it makes my math easy. We like easy, right? Why make it hard? Should I have my unit circle go to a length of root 2? No, that would be awful, right? Then I'd have to rationalize all the time. I only rationalize when I make bad decisions, right? We got a tough crowd today. Tough crowd. So, if tangent is opposite over adjacent, and the adjacent length is 1, then the tangent is just the length of the opposite side, right? In this red triangle. So, length of this line, this tangent line, is tangent. That's why they call it tangent. That's why they call it tangent. Okay? That's all I want to talk to you about that. That's why they call it tangent. And yeah, we talked about all that. We're not doing this page. The next page we are not doing. We are not doing that at all. This next page, we are not doing number 6. This next exercise, exercise 7. We are doing exercise 7 for homework. I got your attention there, didn't I, Jeff? Yep, as soon as I heard homework, his eyes just went right up here. So, I am going to do part A with you today in class. Okay? You guys are going to get to do, I'll do this in blue, B and C. We are going to do A together. You are going to do B and C yourself. Of number 7. Of number 8, number 8, I am going to do A in class with you. You are going to do B and C. So what is the assignment for this lesson? ABC. Good. We are listening. I like what I hear. All right, good. So let's do 7A, and then let's do 8A. Can you join the Navy? No. You just give them a free swag? Yeah. All right. You know I was in the Navy, right? Yeah. You didn't know that. Yeah, I did. Did you? So, yeah. All right. So, 7. Rotate the initial ray about the origin the stated number of degrees. For 7A, it's 30 degrees. Draw a sketch and label the coordinates of point P, where the terminal ray intersects the inner circle. What is the slope? What is the slope of the line containing this ray? This is the fun part. So let's start with the unit circle, right? And 30 degrees looks about like this. So if this is 0, 30 is about yay? Up there? So now I'm going to make a triangle out of this, a right triangle. I'm making a triangle out of this, right? Now, if this angle right here is 30 degrees, what is the tangent of that angle? How do I find the tangent of that angle? Sine theta, cosine theta. Okay, so tangent, and our theta is 30 degrees here, right? Equals the sine of 30 degrees divided by the cosine of 30 degrees. Okay? Now, now I want to go back to triangle speak. I don't want to go into sine and cosine speak. I want to go into triangle speak. What is another way for me to say what is the tangent of that triangle or that angle? Opposite over adjacent. So, Caden, finish the thought. If the red side and the green side, tangent is what? Red over green or green over red?
Red over green.
Red over green. Charles, please. Thank you. Are you talking math and I just not know it? There was talking going on over there. So now, what is the length of this red side? I want somebody other than Caden. Caden's doing yeoman's work here. Brett, 1/2. 1/2. And what's the length of the green side? Somebody other than Brett or Caden. Bailey. Bam. Square root of 3 over 2. Square root of 3 over 2. Good. Now, riddle me this, Batman. Back to unit circle speed. What are the coordinates of that point right there? What are the coordinates of that point? Jesse. Root 3 over 2 comma 1/2. So, ding. Root 3 over 2 comma 1/2. And that's that point right there. Now, if I tell you what's the coordinates of that point right there? 0, 0, right? That's the origin. So that one is 0, 0. Why did I go through all that? It asks, what is the slope of the line containing this ray? What is the slope? How do I find slope of this line? What is slope? Rise over run. Rise over run. Which is the change in what coordinate? On top it's y, right? And on bottom it's x. So if I go from 0 up to 1/2, what's the change in y? 1/2, right? What's sine of 30? 1/2, right? Over, what's the change in x? Square root of 3 over 2, which is also the cosine of the angle. So my lesson to you is, what is another name for slope? If the slope of this line containing this angle equals the sine divided by the cosine,
Tangent.
Slope is tangent. Tangent is slope. Whoa. Tangent is slope. Slope is tangent. Finkel is Einhorn. Einhorn is Finkel. You guys don't get that reference. Ace Ventura, Pet Detective. No? So did you get the Finkel is Einhorn, Einhorn is Finkel? Einhorn's a 5. All right, anyhow. All right. So, what is the tangent of 30? Well, it's 1/2 divided by root 3 over 2, right? How do I divide a fraction by a fraction? Times it by the reciprocal. Very good, Kaya. So, tangent of 30 equals, I should move this down. Tangent of 30 equals 1/2 times the reciprocal of root 3 over 2, which would be 2 over root 3. And then, before I rationalize, Jesse, let's make my math easier. What can I do? Caleb, what can I do? Simplify. What do you mean by simplify? The thing and the stuff and the whatchamacallit. Get rid of the 2's, right? Boom and boom. So tangent of 30, I should put 30 degrees up there instead of 30 chickens, right? Equals 1 over root 3, and then what do I do? Multiply by root 3? Why not just root 3, Jeff? Why root 3 over root 3?
That's what I meant.
Because root 3 over root 3 is multiplying by 1. Root 3 over root 3.
Why do we do that?
Because I don't like radicals in the denominator. So then on the top I get 1 times root 3, which is root 3. And on the bottom I get 3. This is the tangent, and what else is this?
Why is it okay on the top?
It's got to be somewhere. It's got to be somewhere. We don't like it on the bottom because I like making life hard on you, Andrew. I want to make life as difficult for you as possible. Okay, we have done 7A. Let's do 8A. And then the rest of the day is work day.
When we solve this, do we always have to find all of them, or can we just do the tangent?
I walked you through the whole thing, but you find the tangent, right? Because tangent is what?
Slope.
Slope is?
Tangent.
Tangent, okay. So, now we're going to do another unit circle, right? It says, rotate the initial ray about the origin stated number of degrees. Draw a sketch and label coordinates of point P where the terminal ray intersects the unit circle. This one's going to be a little bit more trickier here. Do it in green. Go. So, that's 0 degrees, right? Which way? Counterclockwise or counterclockwise?
Clockwise.
Clockwise, because it's a positive angle. Where am I at? 90. Where am I at? 180. Tell me when to stop.
Whoa. Whoa. Go back. Go back. Right there.
Right there?
Yeah. No, that's like 230. Oh wait, no, I forgot that. Yeah, you're good.
So, now, how far past 180 did I go to get to 210? 30. So what's my reference angle?
30.
30. So theta equals 30 degrees. Meaning, actually, no, not theta. We'll go theta sub r for reference angle. Because my theta is 210. Does it make sense how I use that little r there to set it aside from my other theta? See what I did there? Okay, so, riddle me this, Batman. What's the sine of 30?
I'm doing a calculator.
1/2 is the sine of 30, right? But what quadrant am I in with 210? I'm in third quadrant, so my sign has to be negative. So, sine of theta, not theta sub r, but theta, right? Right, Jared? Not the one with the little r, but the regular one, the 210. Matter of fact, why don't I just get rid of that theta and just say 210 equals negative 1/2. What about the cosine? What's the cosine of this guy?
Negative 3 square root of 3 of 2.
Why negative, Bailey?
It's going that way.
It's going that way, right? So the cosine, I'll do that in green. Cosine of 30 is root 3 over 2, but because I'm in the third quadrant, the cosine of 210 is negative root 3 over 2. And the tangent of this angle is what? In trig speak, what is the tangent?
Negative 1/2 over
Use the functions. Use the functions.
sine 210.
Sine divided by cosine. Right. Sine divided by cosine. Let's do this in, what color should I do?
Cyan.
Should I do baby turd yellow?
No, cyan. 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 No, down one.
Down one? Really? That's not, you're not going to see that well. We're not doing that. Sorry, I love the suggestion.
Down one. Down one.
No. Sorry. So tangent of 210 degrees equals sine of 210 degrees divided by cosine of 210 degrees. Is it important that I put the degree sign up there?
Yes.
Yes. We are going to, in our next lesson, talk about another unit of measure for angles called radians. Okay? I need to distinguish between degrees and radians, and I do that by putting a little doohickey above the degrees. And there is nothing for radians. So if you write just 210, I think 210 radians, which is vastly different than 210 degrees. Okay? So make sure you put in the degree sign up there. Okay? Now, tangent equals sine over cosine, which is negative 1/2 divided by negative root 3 over 2. Now we did all the work with the numbers before, right? That equaled root 3 over 3. But what's the sign on this? What's the sign on this?
Negative.
Negative divided by a negative is a positive. So it's also positive. So wait a minute. Wait a minute. So you tell me that this line has the same slope as 30 degrees? How does that even make sense? What kind of angles are 210 and 30 degrees? Starts with an S. Starts with an S.
Submissive. Subculture.
Sepulcher. No, not sepulcher.
Similar.
Supplementary. Meaning they add to be
Diagonal angles. 180.
180. They're 180. 210. Hold on. 210 and 30 add to be 180?
Hey, or you can just
No, but they subtract to be 180, right?
spot angles too. Cook.
Yes.
Or you can just look at it and say that they're both
Yeah,
30
they're
degrees.
exactly. Good point, Andrew. Look at this.
Make life simple.
Look at this. Watch this. Bam. I'm going to extend the 210 ray this way.
They're diagonal.
Boom. What is that angle?
30 degrees.
Right.
Probably more than 30. No. That's that one up.
Bad geometric drawings. But if this is 30, what does that have to be? 30. They have to be, they're alternate angles, right? Alternate angles have to be equal. When two intersecting lines, the alternate angles have to be equal. That's like a geometry theorem or something, right?
Yes.
So, takeaway from this. What is slope?
Tangent.
What is tangent?
Slope.
There we go.